So today we are discussing the topic which is the law of reflection. So let's see what the law of reflection says first. So the law of reflection states that when a light ray reflects off a smooth flat surface, the angle of incident, as you can guys see here, incident ray, the angle of incident ray and the angle of reflected ray would remain the same. Like if there is an angle of 45 degree, so the angle of incident is 45 degree, so there would be 45 degree in the refracted ray as well. So 45 degree here would be 2. So incident angle would be equal to the reflected angle when there would be light which will be hit on the surface and then would bounce back. So angles would remain the same. So let's see what things will be same in this case. Okay, if I do have a ray means it has a one starting point and it has not an ending point, but it is in continuous form. So this is basically ray. Okay, so now let me make here. Or suppose this is an incident ray which is coming from the luminous source. Or suppose this is a luminous source, right? So this is a luminous source and this is an incident ray which I'm representing with I. Okay, and this is the surface here. When this light hits this surface, this is bouncing back, right? This is bouncing back. Okay, so of, of course we have an angle here which is being made. So for suppose this angle is equal to 45 degree. So in this case, incident angle is equal to reflected angle. So here the angles are same. So here the angle would be 45 degree as well. So incident angle and reflected angle in this case are the same, as you can see here. Incident angle is 45 degree while reflected angle is 45 degree as well. So now let's talk about in this case what things are same and what things are not same. Okay, let me use another marker. Okay, so in this case, of course there would be frequency of this luminous ray. So frequency will be constant in incident angle and in reflected angle as well. And second thing, there would be speed of this ray as well. So speed would remain the same as well, same as. So this, if I talk about the speed of this incident ray, which is 30 meter per second. If there is 30 meter per second, so here the speed of this ray would be 30 meter per second as well. So the velocity in the incident ray and in the reflected ray are the same. So talking about its energy, so energy would remain the same as well. The energy which will we have here would be remain same here as well. So what the thing will be changing here? Let's talk about that. Let me change the color. Okay, I'm using blue. Okay, so the thing which is only changing here is the direction. As you can see here, direction is varying. So I'm writing here changing. Okay, as you can guys see here, in incident ray, the direction is this. While it hits the surface, the direction changes. The direction is this now. So in this case, only the direction is changing, while frequency, velocity means speed, and the energy and the angle of incident ray and reflected ray are the same. While only what is changing here is the direction. Direction of incident ray and direction of reflected ray is changing only. Okay, now let me tell you guys why this law is important. So this law of reflection is important in many fields, like including engineering, physics, and optics. So it helps us to explain the behavior of light. As I told you, it is very important in the field of optics. So it helps us to explain the behavior of light and is used in the design of various optical devices. We have a lot of optical devices. So in those optical devices, these rays are used. this law of reflection is used, such as we have telescope, we have microscope, and we have cameras as well. Now let's talk about the types of law of reflection. Okay, let me change the color. So now the first type we have, that is regular reflection, and another we have, that is irregular reflection. So what is regular reflection? So basically it is a type of reflection that occurs when a light ray incident on a smooth and flat surface such as mirror or still water. Okay, so in regular reflection the reflected rays remain parallel. As you can guys see here, these all are parallel. These all are parallel, right? So these are parallel to each other, and angle of incident, as you can see here, it is hitting this surface and then it is bouncing back. So the angle between them is again the equal, like the incident angle will be equal to the reflected angle. So I am going to write here, angle of incident would be equal to the angle of reflected. Now let's see how it happens. Wait, let me choose a marker. Okay, this is okay. If I do have a lot of parallel rays, right? These are coming from the luminous source. These all are the rays, and these are coming from the luminous source. And here I have a flat. This is very flat and smooth surface. So when this is touching this, hitting this, this is reflecting back, right? This is also reflecting back. This is also reflecting back. Yeah. So this is also reflecting. So here in this case, as you can guys see, wait, let me move this way. So yeah, now these are rays. So when the incident rays are coming and they are hitting on the surface, this is very smooth surface, very plain. So when these all rays are hitting the surface, they are bouncing back. So here in this case, the angle which is forming between the incident and the reflective, as here some angle would be there and here would be there as well. Like for suppose if I do have angle here which is equal to 20 degree, so here will be 20 degree as well, because the angle is not changing here. So what things are same here? Basically the frequency would remain the same because the luminous source is same, right? So this is the luminous source, so the frequency will remain constant. Velocity will be same as well. Like see, if the velocity of this is 10 meter per second, 10 meter per second, so the velocity of this reflected ray would be 10 meter per second as well. So velocity is same, energy would be same, E is equal to same. So what is changing in this case? Let's see. So in this case, direction is only changing. Direction is what? It is changing, right? So this is same as the law of reflection as I taught you. So frequency is same, velocity is same, energy is same, only direction is same. So this is basically on the regular reflection, which is a type of reflection, right? So regular reflection is also sometimes called specular reflection. It is the opposite of diffuse reflection, which occurs when a rough or irregular reflection will be happening. Like I'll be telling you about that, no worry. It would be appear. So the ability to control the regular and diffuse reflection is important in many areas of science and technology, including optics, photography, and computer graphics as well. Okay, so now we are going to discuss about the second type of law of reflection, which is irregular reflection. As I taught you about regular reflection, so now we are going to discuss about the irregular reflection. So what is basically irregular reflection now? So it is also known as diffuse reflection, which occurs when a light ray is incident on a rough or a irregular surface. Here we were talking about regular surface, so the surface was smooth, But in irregular reflection, the surface is not smooth, but instead it is rough or irregular surface, such as a wall. A wall is there, paper can be there too, or a rock can be there too. So in irregular reflection, the reflected rays is scattered in many directions. As you can guys see here, one is going to this direction, another is going to this direction, then this. So they are scattered into many directions instead of reflecting uniformly in one direction as in regular reflection. As you can see here in the regular reflection, all are going in the one direction, right? As you can see, these all are parallel to each other. While talking about this, the incident rays are parallel, as you can see here, but the reflected rays are not similar. They are like changing its direction. They are scattered in many directions basically. So now I'm going to explain you this. Let me choose a marker. Okay, so now I'm going to write with right. Okay, for suppose if I have this luminous source, right, and all rays are coming from this luminous uh, source. These are the rays, and this is the luminous source. So now in this case, what I have here, the surface is not regular, but instead it is irregular, as you can see here. So it is irregular. So because of this irregular surface, now what is happening? My one ray is going to this direction, and other is going to this direction, and other is going to this direction. So because of this roughness of surface, the direction of these reflected rays are changed. Like this is stated in many ways, in many directions. One is going to this, another is going to this, and another is going to this as well. So now let's talk about their similarities and dissimilarities. Wait, let me use another marker. So here in this case, as I told you, in law of reflection, in all cases, like incident angle would be equal to the reflected angle. So the angle which would be here in the incident ray, that would be same in the reflected ray as well. Like if I have a angle here which is equal to 50 degree, so here would be 50 degree as well. 50 degree, right? Now let's talk about its frequency. So frequency is same because the luminous source is same, so the frequency is same as well, or you can say constant, right? So talking about its velocity, velocity will be same. If there is a velocity of 50 meter per second, 50 meter per second, so there will be the velocity of this reflected ray would be 50 meter per second as well. So the velocity in this condition is the same. What is changing here only? Only the direction is changing because of the irregular surface or the rough surface. So in all cases we saw direction is changing here, direction is changing here, and direction is changing here too. So basically law of reflection says that incident rays angle and refracted angle is the same, while their frequency is also same, velocity is also same. Only what is changing here, only the direction is changing. Now let's see irregular reflection, what role it plays. So irregular reflection plays an important role in our daily life. So it is responsible for the visibility of non-metallic objects, such as we have walls of a room, we have tree leaves, and we have a human skin as well. So the surface roughness and the microstructure of the surface, like there are rocks, okay, microstructure of the surface determine the amount of light scared. As you can see here, it is scattered into many directions. One is going to this direction, another is there, another is there. So irregular reflection is also used in various imaging techniques, such as we have X-rays, we have diffraction, electron microscopy, and we have surface profiling too. So this is all about law of reflection.